In late 2025, the sky begins to change. Not one, not two, but 7 massive comets are racing inward toward the sun, all at once. For decades, comets have been nothing more than silent visitors, icy relics from the dawn of the solar system. But now, something has disturbed their long sleep. NASA's Deep Space Tracking Network has just confirmed what astronomers once thought impossible. A traffic jam in space, all converging near Earth's orbit. Why are these ancient giants all waking up now? And what are they bringing with them? It began quietly, one discovery, then another, and then another. By August 2025, telescopes across the world were picking up comets in rapid succession. Lemon, Swan, K1 Atlas, and one more unlike any other, 3I/Atlas, an interstellar visitor, not born of our sun, but of another star entirely. For astronomers, this wasn't just rare, it was unthinkable. For major comets, all active, all visible, all within months of each other, something had stirred the cosmic dust, and the race to understand it had begun. The inner solar system, once a calm stage for lone wanderers, suddenly looked like rush hour. Each comet cutting its own path, glowing, outgassing, shifting in unpredictable ways. NASA, ESA, the Japanese Space Agency, all scrambling for telescope time. Even backyard astronomers were joining in. Every night brought something new: a burst, a spiral jet, a fragmenting core, a cosmic show that could vanish at any moment. For researchers, this wasn't a spectacle. It was a window into the birth of the solar system, a window that could close at any time. At the center of the frenzy was 3I/Atlas, a comet whose orbit was so steep, so unnatural, that it could only mean one thing. It didn't come from here. Its path cuts backward through the solar plane, a 175 degrees retrograde orbit. Its eccentricity is over 6, meaning it will never return. This is a true interstellar messenger traveling millions of years through the void before falling into our gravity well. And what it carries inside, frozen chemistry from another solar system, may reveal what our own planets were made from billions of years ago. But that's not all 3I/Atlas brought with it. Because as it drew closer to the sun, something else began to awaken. In October, NASA's solar observatories detected a surge of coronal mass ejections. Massive bursts of plasma racing straight through the corridor where the comets now travel. These aren't just solar storms, they're cosmic shockwaves. And when one crosses a comet's path, the effects are instant. Tails snap, jets flare. The entire structure of a comet can change in hours. 3I/Atlas vanished behind the sun on October 21st, invisible from Earth. But models show that it was directly hit by 2 major CME waves in its absence. When it reappears in late November, no one knows what it will look like. Fragmented, mutated, or brighter than ever. Meanwhile, on a mountaintop in Tenerife, scientists were staring at another mystery, Comet Lemon. Through high-speed imaging, they saw something extraordinary. 2 bright jets spiraling from its core, twisting and pulsing in real time. These weren't random bursts. They were rhythmic, like a heartbeat. Every rotation of the comet's nucleus released a synchronized pulse of light, dust, and ionized gas. Spectrographs picked up carbon monoxide, cyanide, and atomic nickel, a cocktail of chemicals boiling into space. It was the first time scientists had ever watched a comet breathe. Farther out, Comet Swan was fading, its time almost over. But even in retreat, it left behind a riddle. 2 tails, one bending, one splitting, as if the comet were being pulled in 2 directions. Some astronomers believe it's fragmenting. Others think it's the solar wind twisting its plasma field. Whatever the cause, Swan became the benchmark. A calm, predictable comet used to study the chaos of the others. Every light curve, every dust pattern, a clue in the puzzle of what's driving this unprecedented alignment. Then there's K1 Atlas, the wild card of the group. It's diving closer to the sun than any of the others, just 33 cents away. Comets that close don't survive easily. They flare, fragment, or explode entirely. And that's exactly what some models predict. Scientists are bracing for a massive outburst, one that could make K1 visible even in daylight, or destroy it completely. Behind the scenes, there's chaos too. Naming disputes, delayed data releases, and tension between research teams. Because whoever captures the next great outburst will write history. To most people, a comet's tail is just light and dust. But to scientists, it's a living laboratory of plasma physics. When sunlight strikes a comet's surface, ices vaporize. Particles become electrically charged, swept up in the solar wind, twisted by magnetic fields. That's why some tails curve, some break, and others snap like whips in the dark. It's not random. It's electromagnetic chaos, playing out millions of miles from Earth. And right now, there are 4 active experiments running at once. For comets tracing invisible lines through the same magnetic storm. With so many comets active at once, the pressure is immense. NASA's space weather teams, the European Southern Observatory, even backyard astronomers, all racing against time. Every night, another alignment. Every morning, another mystery. The International Asteroid Warning Network has issued global alerts, calling for citizen scientists to record, stack, and share their observations. Because this is one of those rare seasons where anyone, even with a backyard telescope, can make a discovery that rewrites science. For many astronomers, 3I/Atlas is more than just a rock. It's a message, a frozen artifact from another world. High-resolution spectroscopy has already found traces of compounds never seen in local comets. Its chemistry matches models of volatile-rich regions deep in the Milky Way's thin disk, suggesting it may have been ejected from a forming solar system 100 million years ago. That means the light hitting your eyes as you watch it has touched matter older than our sun. As the year closes, the stage is set. Lemon will pass its peak on November 8th. 3I/Atlas will reemerge by late November. K1 Atlas dives toward the sun on December 31st. Each event will be different, unpredictable, and each could end in a burst of light seen around the world. But what makes this year special isn't just the comets themselves. It's the collaboration, the way professionals and amateurs have united, turning the sky into one shared observatory. Every few centuries, the solar system opens a door. For a few short months, we glimpse the chaos that shaped everything we know. This is one of those moments. A storm of comets, a symphony of ice and fire, each carrying messages from worlds we'll never see. When 3I/Atlas vanishes back into the void, it may never return. But the data, the images, and the awe it inspires will outlast us all. So the next time you look up at the night sky, remember you're not just seeing light, you're witnessing history. If you've made it this far, hit subscribe, because the next chapter in this cosmic story is only just beginning. Don't just watch the universe, be part of it. Follow for more discoveries, NASA alerts, and the mysteries that still defy explanation.